Welcome to Advanced Functional Data Structures and Algorithms, a video course by Packt Publishing. I'm Mark Thomas and I'll be the presenter for this course. Atul S. Kott is a self-taught programmer and started writing software in C and C++. A Linux aficionado and a command line guy at heart, Atul has always been a polyglot programmer. Having extensively programmed in Java and dabbled in multiple languages, these days he's increasingly getting hooked on Scala, Clojure and Erlang. Atul is a frequent speaker at software conferences and a past Dr. Dobbs Product Award judge. Raju Kumar Mishra is a consultant and corporate trainer for big data and programming. After completing his BTEC, he worked for Tata Steel. His deep passion for mathematics, data science and programming took him to Indian Institute of Science. After graduating from IISc in computational science, he worked for Oracle as a performance engineer and software developer. He's an Oracle Certified Associate for Java 7. He's a Hortonworks Certified Apache Hadoop Java developer and holds a developer certification for Apache Spark and Revolution R Enterprise Certified Specialist certifications. Now let's talk about the functional data structures and algorithms. So, functional data structures have the power to improve the code base of an application and improve efficiency. With the advent of functional programming, and with powerful functional languages such as Scala, Clojure, and Elixir becoming part of important enterprise applications, functional data structures have gained an important place in the developer toolkit. How do we express traditional algorithms in a functional setting? Won't we end up copying too much? Do we trade performance for version data structures? This course attempts to answer these questions by looking at functional implementations of traditional algorithms. It's time to see what we'll be covering through this course. So, our first section, Graph Algorithms, looks at some common graph algorithms. We look at graph traversal and topological sorting, an important algorithm for ordering dependencies. Then we'll move on to random access lists, which looks at how we could exploit binary search trees to access a random list element faster. The third section, queues, looks at first-in, first-out queues. This is another fundamental data structure. We look at some innovative uses of lists to implement queues. After this, we'll move on to streams, laziness and algorithms, where we'll look at lazy evaluation, another FP feature. This is an important building block for upcoming algorithms, so we refresh ourselves with some deferred evaluation concepts. Our next section, being lazy, which deals with queues and dequeues, looks at double-ended queues, which allows insertion and deletion at both ends. Following this, we'll explore about red-black trees, which will show how balancing helps to avoid degenerate binary search trees. This is a comparatively complex data structure, so we discuss each algorithm in detail. After this, we'll dive into binomial heaps, where we'll cover heap implementation, offering very efficient merge operation. We'll implement this data structure in a functional setting. While the last section, sorting, talks about typical functional sorting algorithms. You need to install Scala and Clojure. All the examples are performed with Scala version 2.11.7, and the Clojure examples are performed with Clojure version 1.8.0. You don't need any IDE, as most of the examples are small enough, so you can key them in the REPL. You also need a text editor. Use whichever you're comfortable with. You're expected to have a basic knowledge of object-oriented programming, and some basics of data structures, like arrays, pointers, lists, etc. By the end of this course, you'll be able to use different types of graphs, queues, and sorting algorithms to develop efficient programs, which will ensure increase in productivity and save resources. So what are we waiting for? Let's begin this journey together, and I hope to see you there.